Hi, David Vizard here, and you are watching Power Tech 10. If you can lend me your ears, and your eyes for that matter, see I'm quoting Shakespeare here, for just 20 minutes or so, I will give you the benefit of over 60 years of building race-winning and high-performance street engines. Before I go any further, I'd like to make a statement on our policy for testing speed equipment parts, or in fact any parts related to automotive endeavors. And it goes something like this. If it's really good and it's worth the money, we promote it big time. If we're telling you what you should buy, that means we're stopping you buying what you shouldn't buy. Think about that. If it's mediocre, we don't have time for it. In the main, that is. If it's a rip-off or BS, we are going to expose it big time. Please note, that is a hard and fast policy. In this edition 73, I'm going to take you through all the steps to install a cam properly. Now, I guess my properly is a little more comprehensive than most other people's properlies. I guarantee you, you're going to see stuff in this video you have never seen before unless you've already watched this video. And I'm talking about top pros here. 9 out of 10 will find something they didn't know before. God, that sounds like I'm bragging, but the bottom line is that's the way it is. Anyway, carry on. If you've got any complaints about that, put them in the comment section below. So I've got 3 camshafts here that are going into that engine. Now, you'll notice some of the hardware on the table here. I don't know if it's in frame, but let me just check. Well, maybe it wasn't fully in frame, but let me tell you what we've got here. This is a Cam's adjustable timing chain. I can advance and retard the cam about 7 or 8 degrees. This is the split cover that facilitates the use of this timing chain. It splits here so that you can not only advance and retard the cam without having to dismantle the front end of the engine, you can also change the camshaft just by taking this off, undoing these bolts, lifting that up, hanging the timing chain so that it stays on the bottom gear, and pulling the cam out once you've undone the little retainer for it. So, why am I going to all this trouble to test 3 cams? Let me tell you. Any test which is done without the aid of an adjustable cam timing deal does not give you proper test results. They can be skewed enormously. With all that said, let's get to it. Before we get going here, a couple of points I want to raise. I think it's time to take a closer look at the cam specs so that you know what I'm doing here. Glasses on. Right. The camshaft here is a flat tappet cam. When I get a flat tappet cam from Comp, I always take advantage of their case hardening service. So these are case hardened flat tappet cams. The intake duration at 6 thousandths is 268, exhaust 273. And this equates to a 50 duration of 224, 230. Load lift, I'm going to be using 1/6 rockers on here, so the lift is going to be about 5, 20 on the intake, right? And on the exhaust I use 1.5s, and that'll be about 490, right? But I'll do some experimenting there. Now then, the question is, the closest cam for this, what will be a 9.5 to 1 compression with these flat top pistons, is going to be about 107 degrees. Lobe center line, that will be the optimum, right, with those size valves. Now if they had the bigger valves in, like 20216s, then we'd be looking at probably about 108. Now I've only got 106 and 108, and 107 falls between the two. So what should I use? Well, let me make a statement here that you need to keep fixed in your mind. It is better to have a camshaft which is 1 degree too tight than 1 degree too loose if output is your number one consideration. Now, this is not a very long cam at 268 and 273. So yes, we will suffer a little idle quality if we put the 106 in, but we're not likely to suffer any power loss. As for the idle quality going down, well, it's still a short cam, so we will still have more than acceptable idle. First step is to install the cam. As you do so, paint up the lobes with good moly grease. Now there's plenty of cam lubes you can use, and that's okay, but this stuff always works. And if you're going to follow the routine that I use for the break-in, this is more than adequate for the job, and it's kind of got a safety margin to work with. There we go. Notice I've got an extension here, just a simple plain old bolt to get a better purchase on it. But the last bearing is the one that is the nuisance, but we will get it. There we go. Right, now see that it's a bit sticky because of all the grease on the bearings, but I tried it beforehand. It spins nicely, so that's how it's got to go, nice and smooth, and the only sticking there should be the grease. Here are the components that we're going to deal with next. Here I've placed the retaining washer on top of the thrust bearing, and the chain here has not been pre-oiled, right? It'd just make a mess of this white paper, so I have not pre-oiled it yet. Normally I would soak these in oil, an oil bath, for about 10 minutes before I installed them. Well, the bottom crank gear that I was waiting for finally came in. That took a week to get, so be aware that they sometimes aren't easy to get. As a provisional check that everything's rotating smoothly, your first move should be to put on the cam gear and see that the cam turns smoothly. Now it won't turn necessarily easily because you've got all that break-in goo on the cam bearings, but it should turn smoothly with no hitches, like this. Next move is to install the bottom gear. Right, what we're going to do is we're going to check that these two gears are square with each other. Right, so the first job to do is to smear some grease on the inside there. For greasing the gear, you can use something like this. Apply it with a brush, and a dab on the crank won't hurt either, especially around the keyways. Now when it comes to installing the gear, we need to make sure that A, we have it in the right position, and B, we use a suitable tool like this. You can get this from comp cams. The particular gear I'm using is a 3 keyway one. That's because that's what I could get the quickest. There's no reason for you not to use a single keyway gear, but be aware that those that were on the emission engines, and I can't remember the years they were on, but it was quite a few years, spanned maybe 10 years. The keyway times the cam in 4 degrees retard, right? That's a little inconvenient, but not the end of the world. This is the gear I recommend that you get. Now, we are going to, each keyway here times the cam in different. There's an advanced one, retard one, and a straight up one, right? And this is the one we're going to use. So take a look with your glasses on, like I am, and check you've got the right keyway. So let's now install it. Tap the gear into place. Next, temporarily install the cam gear onto the cam. We're just going to check alignment here, so these only need to be gently snugged out. Then we check to see how well aligned these are. This is absolutely smack on here. But before installing our Camshaft adjustable timing gear, there's a couple of points I want to raise. Turn the gear over and you will see that it has a Torrington race on the back here to take care of the thrust bearing duties. Now normally the stock cam bears on here. It does so by the fact that there's a taper on the camshaft that way that pushes the cam towards the back of the engine. So the clearance here is taken up. Otherwise there's nothing stopping it moving backwards and forwards. Well, it's a nice cheap way of doing it, but it's not 100%. So this if you have a roller bearing, a roller camshaft, you need something to control the end float. This is why this is a good gear to use, because it can be used with either a roller or a flat tappet, and it allows the flat tappet cam to be stabilized in terms of end float. So since I almost always use an adjustable timing gear, I almost always use one of these rollers. So that's another reason for getting one of these Cam's adjustable gears. This is the cam button I'm going to use. It is a roller type one, but you can get plain nylon ones. Now, to be honest, the nylon ones work very well and are cheap. The next move here is to turn the crank over until we get to TDC. Now, we can pretty much see when that is, and what we will find is that there is a 0 on that gear there, which needs to be pointing straight up, right? That's the position to get it. Now, we've just got our top gear loosely installed. So now we're going to turn the cam, right, until these dots here line up with that one. So far so good. Now comes the fiddly part. Now here are 4 timing chains. This is the one that came in the Cam's kit. So it's brand new, never used. This one here has done about 2 hours on a break-in. This one here has done about 25 hours, and this one's done about, I'd say 50 or 60 hours. Now, they're all top-notch timing chains, but they're all going to be slightly different lengths. So I'm going to try this one for, no, I think I will go with this one. This is the one that's been broken in, but it's also one that I got from Camshaft. So we will see how a broken in gear, timing chain setup fits to a brand new set of gears. So let's go and tackle the most difficult part of this installation, and that's fitting the chain on. So here we go. First move, place the chain on this gear. Now remember, we've turned this camshaft and the crankshaft so that the timing dots should align. So we get that timing dot, and if we can fiddle it on correctly, we should end up with that being installed like so. No, we got it round too far. Let's try that. There we go. Timing gear located. Next move, we install our thrust button and the thrust button retaining washer. Here's what the loosest chain out of the 4 delivered. Now, I don't want to use this because this engine has to have the least mechanical noise possible. The timing chain that I'm going to show you next will be just right in terms of both noise and power output. This one here won't sacrifice any power output. In fact, it may actually be slightly better. But what you will do is get spark scatter at idle and on the overrun, right? So it's going to be a bit noisy. On a race car you won't hear it. So if your timing chain ends up like this, with about that amount of slack, although there's a lot of people tell you that's too much, on the dyno it tells you slightly different. That works fine, but it's noisy. Well, the timing chain I picked proved to be just right. Now I'm hoping you can see the amount of slack in there. Right, I'm not putting a lot of force on it, but you'll notice that this gear wheel is not moving any that you can perceive. That's how we want it. The previous one I showed you had too much slack, but it would work. Next move is to place the securing plate in position. Now it's time to install our fixing bolts here. The first move is to put a dab, and I just mean a dab, of blue Loctite on the thread. There we go. Now then, we'll put that in and just provisionally tighten it up. Last job here is to torque the fixing bolts to the figure specified in the instructions. I think it's possibly different for different types of engines that Camshaft makes these deals for. Anyway, that's 18 foot-pounds there, and that snugged them up nicely. Right, there's no need to go mad on tightening them. They don't need to be super tight, and they also don't need to be seized in there with Loctite, so that's why I used the blue. First install the timing wheel adapter onto the crank and just nip it up so it's snug. Here's our degree wheel. Ignore this second scale in here. That's something I've added, and I'm going to show you what that does after. But for now, I'm going to do this as if this was a conventional single disc timing wheel. Install the degree wheel and a pointer. Your first move here is to establish an accurate TDC. What we're going to do now is install the dummy lifter so that we can check how much lift has taken place. To do that, you can use one of these Camshaft dummy lifters. This one has got a radius on the bottom, so it can be used on a flat tappet cam, and it must be used on a roller, right? Now, you can use a lifter. Best to use a solid lifter to do this and a push rod, but I'm going to show you how to use this. Insert it into number 1 intake like so. Set the dial gauge on the end of the dummy lifter, then turn the engine backwards until you get onto the base circle. That's when the lift stops occurring and you're now as low a lift as it can be. So now turn that to 0 like so. Starting in the base circle with it set on 0, turn the engine over until you find peak lift. That's 100, 200, 300. We are at 320, 327. Cam card says 326. That's pretty good. Right, now we're going to start the business of timing it. So what we do now is we turn to full lift again, right? And we set the dial indicator to 0. 0. Now then, what we are going to do now is turn the engine backwards until it's almost a whole 100,000ths down. And we're going to raise it up until we get to 80. Now that is 20 degrees before TDC. And we note the reading on this dial here, which will be, there's 90, 91.5. We write that down. We then turn the motor in a forward direction until full lift and back down to 80. We then take another reading. This time the dial gauge on the outer scale reads 130. So 92 was our first reading, 130 our second. We add them together, that's 222, divide by 2, and that gives us 111. That's nowhere near where we needed it. Okay, so why were we at 111 there and not 102? Stack up of tolerances. Now, I've got to admit, this is a bigger stack up than I usually see. But let's go through and see where all the things that can be off slightly for it to all stack up in a direction totally unfavorable to your quest for horsepower. First off, the keyway in the crank, that's about a 1 degree deal there. The keyways in the gears there, I'm guessing that they could be about 1 degree. The camshaft could easily be a degree off. Now it was supposed to be ground 4 degrees advance, right? But it might have mistakenly been ground 0. Now I didn't check that because I've got an adjustable wheel here and I don't care where the cam's ground. I'm going to time it in so it's right regardless, and that's what you're going to do. So right away we've got 3 degrees, and that would lower our situation to being timed. Let's say all of those are working in our favor, right? Instead of being off the wrong way, they were off the right way. Same error, right? That means our cam could be 6 degrees more advanced without any of this artificial correcting it timing. So 6 degrees more advanced makes it 105. So now it's only 3 degrees behind where it should be. Is that a problem? Well, assuming that peak power is at 102 degrees advanced, right, and in this case that's not a big assumption, it almost will be, plus or minus about 1 degree. Being retarded kills off power faster than being advanced. And I'm talking about performance down the drag strip. Now, your retarded cam, the deal about it making more horsepower at the top end compared with less, is not as prevalent with this cam, because this cam has, for this engine, near perfect timing. So if we retard it, all the sequences go off. If we advance it, all the sequences go off. Whereas if it was on the wrong lobe centerline angle, if we retard it, all the exhaust sequences can get better. If we advance it, they can all the intake gets worse, right? So it doesn't work as well. So what we can say here, the more accurately your cam's events are timed, the more important it is to put it in right. How much difference can it make? Well, with the super trick valve seats that I produce on my Goodson 3D equipment, I can get to a situation where the cam company's advance figure compared with what is actually required is 5 degrees off, and that 5 degrees on a high 500 horsepower engine is 25 horsepower. You want to throw 25 horsepower away? No, I'm not saying you're going to, but if somebody put this combination together without an adjustable and didn't check it, they will be 30 horsepower down. No problem whatsoever on a 350 with about a 10-to-1 compression. So what you need to do here is to reckon that you're always going to have a problem with getting the right timing. So time it in. Now, I've got to say that 11 degrees is a long way off, and I probably only see one in, at a guess, 15 engines like that. So it's very fortunate, as it turns out, that this is an example that I can show you. Install the degree wheel and a pointer. From a retarded position below full lift, bring your dial indicator up to 80, that's 20 before TDC. As before, it's going to read 92. Now then, set the inner wheel to read the same, 92. Now remember, this scale is backwards and double the size, so 92 is to the left hand side of 90, not the right hand side as here. Now let's bring it on round until it comes back down to 80 again. That shows just a tad over 111 degrees, which is pretty much what we calculated. Now come on, admit it. Wasn't that just a piece of cake? As far as the double wheel degree wheel goes, Moroso did make some of these big ones for big blocks, but I think they've stopped making them now. So I made mine out of a Camshaft deal. They don't need to be quite that big, but if anybody wants to buy the rights to make these, any reasonable offer will do. Right, so just in the comments below, just say that you'd like to make it. That's davidvizartseminars.com. How do we fix all that? Simple. A little bit exasperating, but nonetheless simple. Right, first off, we've got a 3 keyway gear there, bottom gear, which means that if we put it on the advanced position, we go from 111 degrees down to 107. Right, that's still 5 degrees too much advanced. However, our comp cam's degree wheel will go a little over 6 degrees. Actually, I think it goes to about 8. Either way. So we can correct it from that. Now, had we just left it at 111 degrees, how much power would we have lost? Well, we spent all that money on a very functional comp cam's cam, right? 75% of the power we could have gained over the stock cam, we will have thrown out the window. So, and that cam, I know from past experience, that cam spec works very well in a 350. It makes big torque numbers and big horsepower numbers for such a short cam, as you will see. So timing in your camshaft is a very worthwhile deal. And with that, I'll leave you. Right, so don't forget to like, subscribe, notify, and share. Right, thank you very much for watching. I will see you on the next Paratech 10.